Hey everyone, welcome back. Sorry I'm not there with you physically, but I am here and I wanted to walk you through what ionic bonding looks like with something we call Lewis dot structures. So in the last worksheet that you did, that you were just working on with the Bohr models, you were drawing not only the valence electrons, you were also drawing the core electrons and those different energy levels that go into atoms. Now, when we do it by Lewis dot structure, we're gonna pare it down, and we're gonna pare it down to just the valence electrons. And that's what you're going to represent on this worksheet. Okay, so what we're looking at here is representing the transfer of electrons with ionic compounds. So for the very first one, we've got potassium and fluorine coming together. So potassium, remember this is only valence electrons. So potassium is in the very first column of the periodic table. It is right here. Right, so it's in the very first column of the periodic table. That means it has one valence electron. So I'm going to put that one valence electron in there. Okay, and it's going to pair up with fluorine. Fluorine is in the 17th column. And remember, the rule for the P block is that number minus 10 to figure out valence electrons. So this would be 17 minus 10, so 7 valence electrons. Or you look at 7A there, that tells us that it has 7 valence electrons. So fluorine is right here in the in that 7A column, which means it has 7 valence electrons. So I'm going to put fluorine on there, and I'm going to draw its 7 valence electrons. Okay, need to make sure that I'm going to put that in there just so it makes sense. Okay, now it's best to do this with different colored pens, just so you can easily track the movement. Okay, so what's going to happen then is potassium wants to get rid of its electron. Fluorine really wants that electron. It's going to give its electron over here to that fluorine atom. Now, the resulting compound will be a compound because those ions, the cation potassium and the anion fluorine, are going to be together based on the disparity of their charges, really. So we're going to see the potassium over here, it got rid of an electron, so it now takes on a positive. Oh my gosh, that's a terrible positive, sorry. This has been a hot minute since I've done Google Meet and screencast teaching, so bear with me. So there we have the potassium with the positive charge, and since the fluorine took on another electron, that means it's taking on a negative charge, and that would give fluorine the negative charge. And again, it's the difference in those charges that are keeping them together in the compound. Now, if we lose more than one electron, so if you take a look up here, where we've got calcium losing 2 of its electrons, and one electron is going to one chlorine atom, the other is going to another chlorine atom. If you need to represent things with, more than one atom represented, this is what it's going to look like. So you can see how calcium has 2 valence electrons. It's in that second column. Chlorine is in the 7th column. So each chlorine atom only needs one more electron. So this chlorine atom is going to take one of the electrons. This chlorine atom over here is going to take one of the electrons. And the resulting ionic compound would be due to the disparity of charges here. And so this is the only time I would want to see you write the charges in the resulting compound. Okay? Okay, so hopefully that was clear enough. If you have any questions, just get a hold of me either through Remind or through email, and I'd be happy to help you out. Otherwise, I hope that things are going well, and I will see you back next week. So have a great day, and I will talk with you later. Goodbye.